So in this problem, it's asking us how long does it take for a deposit of $500 to double at 9% compounded continuously. And we would be using this formula right here, A is equal to PE to the RT, to solve something like this. How we know that is because of the words compounded continuously. All right, and this is the continuous compounding formula. Okay. So if we identify the pieces here, so that if we have a deposit of $500, that's actually the principal. And the amount then, because they're telling us that it's going to be doubling, if we just double this $500 and get $1,000, then that would actually be our amount. So we have these two values that we can plug in. We also know the interest rate, and the interest rate here is 0.09. Okay, so we can plug all of those in and then solve for t. So this problem will look like 1,000 equal to 500, and then we have e to the r 0.09 times t. Okay, now we're solving that, so I'm going to divide both sides by 500. So we get 2 is equal to e to the 0.09 t. Okay, what we're going to do now, because the variable is in the exponent, so that's what we're solving for, it's in the exponent, what we need to do is use a logarithm to bring this down. And I'm actually going to use a natural logarithm here, because if I take the natural log of e once I bring this down is equivalent to 1. So we have this rule that allows us to bring this exponent down out front. So this becomes the ln of 2 is equal to 0.09 t times the ln of e. And this is what I was referring to now. The ln of e is equivalent to 1. So that's the reason that I used a natural log instead of just a regular logarithm, because that now becomes 1, and I have 0.09 t is equal to the ln of 2, and I can solve that now just by dividing by 0.09 on both sides. Okay, so we're looking then at t is equal to, if we do that calculation on our calculator, so the ln of 2, take that and divide by 0.09, and we get 7.7016, and I didn't look in the directions to see what they were talking about in terms of rounding per year, if they did mention it, but you would want to round, I'm just going to say, you would want to round to however much they asked you to, but I'm just going to call it 7.7 years here.